want you to turn to page 149, try problem number 45. Right. Integration is going to be from negative pi over 4 to pi over 4. Try to determine which function is going to go first, which second. Pause the video, and I will put the work on the board. All right, so 2 cosine x minus secant x in parentheses dx. Now try integrating it and try to do the work. I will do the work on the board. Pause the video after you've completed the work. Come back and check your work. Okay, you can break this up into 2 integrals if you want. Integrate 2 cosine x becomes 2 sine x. You integrate minus, you integrate secant of x. You can look on your integral tables. It can be natural log, absolute value of secant x plus tangent x, absolute value, and you can integrate it from negative pi over 4 to pi over 4. This is absolute value because you can't have a negative logarithm. So plug in pi over 4. All right, you're going to get 1/2. Okay, you need to remember the trig formula for 45-degree angle, which is pi over 4. Side opposite will be 1, side adjacent is 1, hypotenuse will be square root of 2. So sine of x is 1 over square root of 2. Tangent of x is 1 over 1. Secant of x is square root of 2 over 1. So now we want to plug in pi over 4 for the sine, which is going to be 1 over square root of 2, minus the natural log of secant x is going to be square root of 2, plus the tangent of pi over 4 is 1. Now you want to subtract it, so it's minus. How do I get that minus there? So it is minus square root of 2 all right, minus square root of 2 minus natural log of absolute value square root of 2 minus 1, then parentheses, I removed the brackets, I should have said brackets, becomes positive square root of 2, positive natural log of absolute value square root of 2 minus 1. So you're going to get 2 square root of 2. Now I'm going to bring this here and put that one over here. That enables me to use this as a division. What I want to do is rationalize the denominator. Right, so when I multiply this out, I'm going to have 2 square root of 2 plus natural log of absolute value of 3 minus 2 times square root of 2. And I do the arithmetic and I will end up with 1.066. All right, try problem 8 on page 155. With integration by parts. This is the formula, we did it last class. Now it doesn't matter, what you want to do is you're trying to figure out whether to use, which one's going to be U and which one's going to be V. All right. You're guessing. Try one, if it doesn't work, go back and try the other one. All right, so give it a try, see what you get, pause the video, I'll do the work on the board. All right. I decided U would be X, so du will be 1 dx. Then I said dv is going to be e to the 3x, which means v is equal to 1/3 e to the 3x. I take them, I plug them back into the formula. All right, it's going to be ux, which is x. Then want vx, which is 1/3 e to the 3x. Then I want the minus the integral of vx, which is 1/3 e to the 3x. And then I want u of x, which is 1. So I just have to put the d of x. So I integrate this, I get negative 1/9 e to the 3x plus c, carrying the 1/3 x e to the 3x over. And that's your answer. Try number 10. All right, that's number 10. Select a u, select a v. All right, and see how you do with it. I will put the work on the board, pause the video, come back and check your work. All right, how many of you got this far? Now, at this point here, I have to again use the integration by parts on this portion of the problem. So again, you want to pick a u and a v and do it again. I'm going to pause the video, give it a try, see how you do. All right, I had placed the 1/2 on the outside, and then when I looked at my notes again, I realized I want the 1/2 to be integrated. I want dv equal to 1/2 e to the 2x. You can do it if you put the 1/2 outside. V will equal 1/4 e to the 2x. If you left the 1/2 out here, it would be 1/2 e to the 2x. You multiply them, you'll end up with your 1/4. Okay, proceed from there. Pause the video again, give it a try. All right, I left off the 1/2 here, so I put it back in. All right, so now you have 1/2 parentheses x squared minus 2x plus 1 e to the 2x. This again is an algebraic expression times the transcendental. So you want to use integration by parts. U is equal to 2x minus 1, du is equal to 2 dx. dv is equal to 1/2 e to the 2x, v is equal to 1/4 e to the 2x. So I bring this down, I apply integration by parts, all right, to this portion. I'll get 2x minus 2, hold on. All right, that should have been a 2, so I changed it back. Times 1/4 e to the 2x minus the integral of 1/4 e to the 2x 2 dx. All right, multiply the 2 times 1/4. All right, I'm going to get 1/2 e to the 2x. I integrate it again, I get back to the 1/4 e to the 2x. So I have 1/4 times 2x minus 2 parentheses e to the 2x minus 1/4 e to the 2x. Now I have to combine all of that. Remove the brackets, this is going to become minus, this will become plus. All right, so I end up with this here, factor out e to the 2x, then I simplify all of it, and this is your answer. If you didn't get it right, try it over. So you have to use the integration by parts formula twice. All right, we're back to page 168. Going to look at problem number 2. We're going to use trigonometric substitution. Now, if you have a right triangle, if this is a, this is x, the hypotenuse is going to be the square root of a squared plus x squared. For the tangent of theta, it's going to be x over a. Theta will be greater than negative pi over 2 and less than pi over 2. All right. This means that x is equal to a tangent theta, which means you could put this here in for x. You could substitute it. The secant is equal to the hypotenuse over the adjacent, which means that the hypotenuse is equal to a times the secant of theta. Notice that and that are very similar. All right, this can be considered 1 squared, and you can make this 3x parentheses squared. So you'd have your x squared, and you'd have a plus. All right, so I've taken u, made it into 3x. All right, du is equal to 3. So when I put the du in there, I substituted for the 3 dx, and I have over square root of 1 plus u squared. This looks like this. All right, so now I'm going to substitute again. I'm going to put u is equal to tangent of theta. So du is equal to secant squared theta d theta. All right, which is this here. Only I'm going to square it. So I'm going to put in d theta over square root of 1 plus tangent squared theta times 1 over cosine squared theta. These two are the same. Okay. So now I'm going to, all right, so I have d theta over square root of 1 plus tangent squared theta. I forgot to put on the board trig identity. Tangent squared theta plus 1 equals secant squared theta. So I want to take the square root of secant squared theta, which is going to be secant theta. All right, times cosine squared theta. Well, secant theta is equal to 1 over cosine theta. So I'll cross it out and I'll have d of theta over cosine theta. Well, cosine theta is equal to 1 over cosine theta is equal to secant theta d theta. And I can now look up on the integral tables natural log, and I will end up with this. Now what I want to do for secant theta, all right, that's going to be equal to the 1 plus three x. Hold on. Okay, secant theta is going to be equal to the square root of a squared plus x squared, which is square root of 1 plus 9x squared. I forgot to put my 9 in there. Plus tangent theta, which is going to be equal to 3x. The tangent of theta is equal to u. U is equal to 3x. All right. Now what I would suggest you do is do this one over a few times, and I'll give you a couple of due for homework. All right, your homework is page 149, number 45. We did that. I did that on the board for you. Page 155, number 7, 8, 9, and 10. I did 8 and 10 for you. Page 165, numbers 1, 2, and 18. Now, 18 is done on MIT's website. I will send you the link for it so you can look at it. Give it a try. It's done basically the same as number 2, if I remember correctly. Let's see. Yes. Basically using the same principle. Have a good day, and please, I will send you an email with the link and probably some additional work. Be safe.